Hi, everybody. Mr. Wyatt here. And today we're going to be talking about some statistics, how we analyze data sets. And first of all, I want you to notice I'm wearing a tie today. I was getting some feedback that there were a number of students that kind of liked it when I wore a tie. So today I'm wearing a tie especially for you because you matter and I care about you. All right. So, anyway, let's go ahead and take a look at the different terms we're going to be discussing today. We actually have quite a few terms, so I want to run through these words with you and help you to understand what each of them means. First of all, mean in math means average. We're finding the average of a group of numbers. Okay? And to do that, we add them all together. All the numbers get added together, and then we divide by how many numbers are in the set. Now, don't worry about trying to write all these definitions down right now. You can always come back and watch this video again and write all these down if you forget what any of them are. Okay, they'll be easy to find in the video. I'm doing this right here at the beginning of the video. So mean is just a math term for average. Add numbers together, divide by how many numbers there are in that set. Median is the middle number in the set after you put all the numbers in order from least to greatest. Okay, put them in order, least to greatest. Grab the number that's in the middle. That's your median. Mode. The mode in a data set is the number that appears the most frequently or the most often in the data set. Okay? What number appears more than the others? What's interesting with mode, though, is it's possible not to have a mode if there isn't a number that appears more often than the others. But it's also possible to have more than one mode. Okay? And I'll talk about that more as we go through some examples. So an easy way to remember what mode means, just pretend like you talk funny and you say, yeah, I'm looking for the number that appears mode than the others. Mode often. Yeah, I don't know. That's kind of lame, Mr. Wyatt. Hey, but some of you will remember that now. So mode is the number that appears the most often in a data set. Next, we have range. The range is the difference between the greatest and the least values in the set. Take the high number, take the low number, subtract, and that difference between them is the range. You're looking for how far apart the low number and the high number are from each other in a data set. All right, and then we have what's called an outlier. An outlier is a number in a data set which is really a lot different from the others. Okay, if I give a 30-point quiz in class and almost every student is in the 20s, maybe they have a score of 24, 22, 28. A couple kids had perfect scores of 30 out of 30. But then there was that one kid that just was having a bad day and they had a score of 4 out of 30. The next lowest score was a 22. Well, that 4 is very, very much an outlier. It's lying outside of where the other numbers in the data set um, are located. Okay, and those are important to identify because they can really throw off your mean or your average in your data set. And it also can really make your range super duper large too. Okay, so let's take a look at an example here. Speaking of quiz scores, here let's say I give a quiz that is worth 20 points. And here are the different scores. I have 16 different scores listed here. All right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. You can count, you can see there by the count there are 16 scores on this quiz. I want to find the mean, the median, the mode, and the range. So I'm going to write down mean, median. I don't know why my eye has two dots. How did that happen? Mode and range. All right, so anyway, to find the median, remember, we want to put all the numbers in order from least to greatest. I'm going to take all these quiz scores and put them in order from lowest to highest. And what I like to do is just rewrite the list directly below where it is written here, because then I won't miss any. So I'm looking for the lowest score, and it is the 12 here. So I'll write 12 right here. I'll cross them off as I get them written down. Excuse me. The next lowest score, we have a 15 here. Uh-oh, my lights just turned out. Doggone it. I guess I need to stand up and get my lights back on. Oh my goodness, the distractions we face every day. Today is Monday. It's actually a Monday when I'm doing this, when I'm recording this video. And doesn't it look like Mr. Wyatt's having a Monday kind of day? All right, anyway, um, excuse me. Next, I have some 16s. And when I look here, I see I have 1, 2, 3 students who received a score of 16. Again, I'm writing them directly below the numbers in my original list. I don't want to miss any. Next, I have a 17. Let's get that written down. And then 18. Here's an 18. Here's another one. Ooh, here's another one. 3 18s. Interesting. I had 3 students with a score of 16. And now I have 3 students with a score of 18. Remember, mode is the number that appears the most frequently in the data set. I might have 2 modes here because the 16 and the 18 have appeared more frequently than the other scores. Next, I have 19. Let's see here. 1, 2, 3. 3 of them. 3 of the students had a score of 19. I might have 3 modes here, 16, 18, and 19. If I have a huge number of modes like this, then really do I have a mode? Is there really a score that appears more often than the others? You can start to argue that maybe there isn't. All right, then the 20. 1, 2, 3, 4. Oh, good. We have 4 students with perfect scores on this quiz. Must have been a pretty easy quiz, huh? Notice because I was writing directly under the original list, I can see now that it's lining up all the way across. I must not have missed any, but just to be sure, I'm going to count and make sure I have 16 scores. Remember, there were 16 scores. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, good. I have 16 scores here. All right, so now we're analyzing this data set, finding the mean, median, mode, and range. Which of these would be the easiest to find? I think it would be the mode. Maybe you were thinking the same thing. And we know what it is. It's 20. Remember, the mode is the number that appears most frequently in the data set. And there were 4 students with a score of 20 on this quiz. No other number appears as frequently. 16, 18, and 19 each had 3 students with those scores, but the 20 was the most common score. Probably the next easiest one to find would be the range. Take the high number, 20, subtract the low number, 12. Find the difference of those 2 values. 20 minus 12 is 8. So I have a range of 8. So we have our mode of 20. We have our range of 8. Now, when looking at mean and median, probably the next easiest one to find would be the median because you're just looking for the number that's right in the middle in this data set. Now, remember, there are 16 numbers in this data set. So if I want to find the middle, just cut 16 in half. Half of 16 is 8. So I want a number that has 8 scores, numbers to the left and 8 to the right of it. Let's count 8 here. 1, 2, 3, 4, 5, 6, 7, 8. I'll put a line right here. To the right of my line, I have 1, 2, 3, 4, 5, 6, 7, 8 over here. There are 16 numbers in this data set. Whenever there are an even number of numbers, you won't find a number that's smack dab in the middle. You're going to be between 2 numbers. So what you want to do is average those 2 numbers that are in the middle. And they both happen to be 18s here. So when I average them, that will equal 18. So that means my median is 18. Now, when I say to average those 2 numbers, you could show yourself doing the work here to find the average of those numbers. Add them together, that's how you find average, and divide by the total number of numbers there, which is 2 numbers that are in the middle. So 18 plus 18 divided by 2. 18 plus 18 is 36. We'll divide that by 2, and guess what? We get 18. So we have a median of 18. Not too difficult so far. The mean is going to take the most work because now I have to add all of these numbers together. There are 16 of them to add together. And then divide by how many are there. Well, there are 16 of them there. So I know I will be dividing by 16. But first things first, let's add all these numbers together. You can use a calculator for that. I don't want to waste too much time here though, so I'm just going to add them up mentally here. I like to go largest to smallest. 20, 40, 60, 80, 99, 118, 137, there's a high stake situation here. I could screw up when I'm adding these. And now I just interrupted myself, so I have to start over. 20, 40, 60, 80, 99, 118, 137, 155, 173, 191, 208, 224, 240, 56, 271, 283. I hope I didn't screw that up. Anyway, we're going to divide by 16. 283 divided by 16. I'll use my calculator for that. 283 divided by 16. 17.6875. I'll just go ahead and round to the nearest hundredth and put 17.69. Now, what I'm noticing here is my mean is a little bit less than the median. The median was 18, but they're pretty close together, aren't they? There actually is a good reason why the mean or the average is a little bit smaller than the median. The reason it's a little smaller than the median is because we have an outlier in this data set. Notice the score 12 is much lower than the other scores. That's why it's called an outlier. The next lowest score was a 15. You had to drop down 3 points to get to that 12. Now that 12 is pulling the mean or the average down. Okay, but it does not change the median. I mean, we could make that 12 into a 2. What if the lowest score was a 2? Our median would still be the same though, because we'd still have 8 scores over here that are lower and 8 that are higher. Actually left and right, because these scores and this score are actually the same, not lower or higher. But that would not change the median. It does change the mean though. If this student had done a little bit better, this mean would be up a little higher, probably closer to that 18. Okay, so having an outlier can really affect the score or the average of the scores. Okay, if we throw that score away, our average will increase. I could throw away that 12 and just average the other 15 numbers. Okay, if I did that, then instead of 283, I'd have 271. And to find the average, I would then divide by 15 because I'm not counting that score anymore. I'm ignoring it. And let's see what I get. 271 divided by 15 is 18.06, and then the 666. 18.066666. Now the average ends up being a little higher than the median if I throw this lowest score away. Okay, so yes, an outlier. If there is an outlier in a data set, then I really don't like finding the mean for kind of trying to show what about the middle of the data set is, because that outlier is pulling the mean or the average down. Okay, median is a little bit safer in those situations. So if there is an outlier, I would recommend sticking with the median if you want to describe about where most of the scores fell. How'd the students do on your test? Well, the median score was 18. Well, the average was 17.69, but that's because we had one person that didn't do as well as the rest of the class. They kind of pulled the class average down. So in that case, I like the median. All right, that's enough for today. Good luck on your assignment. I will see you tomorrow.